All right, 7.5 notes. Essential question: how you change the base of a formula? Properties and logarithms. Product property. These are just the same properties used for exponents. If you have a single log and they're multiplying, you can write them as two separate logs and add them. If you have a single log and you're dividing, you can write them as two separate logs and subtract them. And if you have a single log and you have an exponent, you can move the exponent in front of the log and multiply that number of the exponent by the original log. So this is what you're going to do in this section. First one, rewrite the expression as multiple logarithms. You see right here is 2 times x. So we can look at the top one, the product property, where you can write it as two separate logs by adding. So you write x. Okay, so the first one we can write as log base 6 of 2 plus log base 6 of x. We're done because we took the two that were multiplying and we added them together. Okay, the next one, are we dividing? So we'll subtract. So we could do log base 2 of x minus log base 2 of 3. Okay, and the last one, we are multiplying, so we got to add those, and then we have an exponent, so we have to move that in front. So I have log base, well, there is no log base, but remember, if there's no base, it's 10, so we'll just leave it without writing it. So log 3 plus log x squared. And then we'll simplify from there because we can move the 2 out in front. So we'll have log 3 plus 2 log x. Okay, and that's as far as you can do is write it as multiple logarithms to move that 2 out in front. So this one says, which of the following is equivalent to this? Well, this one we can write as a single logarithm by going backwards. So with the plus, well, the first thing we could do is move that 3 as an exponent. So log to the 2/3. Okay, because any number out in front you can move as an exponent. Next thing we can do is simplify that. So we have log 9 plus log 2 to the 3rd power is 8 minus log 3. Then from there, since it's a plus, we can write that as a single log and multiply it. So we have log, let's leave it as 9 times 8. Okay, minus log 3. Then 9 times 8 is 72. So we have log 72 minus log 3. Then since it's minus, we can, since it's subtraction, we can write it as a single log and divide it. So log 72 over 3, which 72 divided by 3 gives us 24, which is D. Okay, so that's how you can rewrite as a single logarithm, just taking the steps. And you can do more of those steps in your head or a little bit quicker, but I just wanted to write out all the steps so you can see that. Okay, this one we're going backwards, rewriting as a single logarithm. So we got a plus, that means we're going to multiply. So let's multiply x and y squared together. So it'll be log x y squared minus log z. Then the next step, since we have a minus, we can divide that. So we're just going to put the z underneath to write a single logarithm. So we're going to have log x y squared over z. And that'll be your answer. That's right as a single logarithm. Okay, the pluses multiply together and the minuses divide. Okay, this one we have natural log, but nothing changes. We're going to multiply those two together. So 2 plus 5 is 10. So we're going to have natural log of 10 minus 2 natural log of x. Actually, let's just move that x right now, or the 2 right there. The 2 out in front can move as an exponent, so it'll be natural log of x squared. Then as we're subtraction, we can divide. So we'd have natural log of 10 over x squared. And that would be our answer. Okay. Because the 2 moved as the exponent. 2 times 5 is 10. Then we divide by x squared. Okay, next one. We have a 5 out in front, so we can move that as exponents. Be log x to the 5th minus log. We can move that 4 as an exponent to the y, so y to the 4th. Then from there, since they're subtracting, we can divide those two. So it'd be log x5 over y to the 4th. That would be your answer. Okay, change of base formula is what we used in the graphing calculator to be able to graph logarithms that were kind of tough to graph otherwise. Basically, you just take the base and you do log of the base on bottom, you do log of the other number on top, and you divide them, you'll get the answer. So if you, some calculators like TI Inspire will do this without this. You can just put log 5/8 in your calculator and give it. But TI-84s and Casios and most others, you have to use change of base formula to solve this. So let's do A first. You just do log 8 divided by log 5. And you put that in your calculator. Log 8 divided by log 5. Large screen. And go to 3 decimal places, so 1.292. Okay, you can do it on another one. Same thing on B. Do log 14 divided by log 8, which equals 1.269. And the last one, do log 9 divided by log 26. This gives you 0.674. Okay, so what we're asking really here is 5 to what power gives us 8? Well, there's no exact power, integer that's going to give that. So 5 to the 1.292 power gives you 8. 8 to the 1.269 power gives you 14. 26 to the 0.64 power gives you 9. So that's what we're trying to find here, but the change of base formula allows us to do that on certain calculators. That won't allow you to do that otherwise. Okay, so there's your exit slip. Rewrite a single logarithm, rewrite a multiple logarithm, and then use the change of base formula. Email me if you have any questions, and that is it.